Today we will talk about functions. The input values are the domain of the function. This is basically what you used to say is the input or your x values. The output values are now being called the range of the function. So this is the same thing as when you used to say the output of a function or the y values on your function table. So look at this function machine and try to come up with the function. When a 2 goes in, a 5 comes out. When a 4 goes in, a 7 comes out. And when a 5 goes in, an 8 comes out. So you can say that the rule is to add 3. But in function form, we would say that this is y equals x plus 3. So if these are my x values or my domain values, when I add 3 to them, that's what I get for y, or the range. So in goes a 2, out comes a 5, in goes a 4, out comes a 7, in goes a 5, out comes an 8, and I could also say in goes a 10 and out comes a 13, for example. Let's look at another one. In goes a 7, out comes a 15. In goes a 6, out comes a 13. And in goes a 10 and out comes a 21. Try to guess the rule. Pause the video. Okay, you could have guessed that the rule was y equals 2x plus 1. So 6 times 2 is 12 plus 1 is 13, 7 times 2 is 14 plus 1 is 15, and so on. For a relationship to actually be a function, it must be true that for each input, there is only one output. So basically, two different inputs can have the same exact output, but there cannot be two different outputs for the same input. Let me give that to you in real life form. If I was measuring a plant on day 1, so let's say x was 1, and I measured that it was 10 centimeters, on day 1, it can't also be 11 centimeters because on day 1 it's 10 centimeters. However, if on day 1 it's 10 centimeters, on day 2 it can also be 10 centimeters, on day 3 it can also be 10 centimeters, that just means it hadn't grown. But even for your height, if you're 50 inches tall on day 1, you can't be 52 inches tall also on day 1, okay? So let's look at some examples. So would this be a function? Well, in goes a 2, out comes a 10, in goes a 4, out comes a 12, in goes a 6, out comes a 10, in goes an 8, out comes a 12. Some of my outputs repeat, but that's okay. The point is here that this is a function because none of the inputs repeat, giving me different outputs. Let's look at another example. In goes a 9, out comes a 0, in goes an 8, out comes a 0, in goes a 7, out comes a 0, in goes a 6, out comes a 0. This would also be a function because though the outputs repeat, none of the inputs repeat, giving me different outputs. And finally, let's look at this example. In goes a 1, out comes a 1, in goes a 2, out comes a 2, in goes a 2 again, and now out comes a 3. Looks like this function machine is broken. You can't put in a 2 and a 2 comes out, and then you put in a 2 again and all of a sudden a 3 comes out. So for this example, you would say not a function. So you can use this even by graphs and say, does this graph represent a function? Well, you can use something called the vertical line test. This hits 2 points on the x, so this would not be a function because here I see 2 comma 2 and then 2 comma 3. So basically in goes a 2, out comes a, in goes a 2, out comes a 3, and then in goes a 2, out comes a 4. So because my x values repeat, this is not a function. You can also use mapping diagrams. So here, if it asked you what is the domain, you can list it in order from least to greatest. So my domain is all my x values, so -1, -3, 5, and -7. But you list them in order from least to greatest. My range is my y values, so 1, 3, -5, and 7. Same thing, I list them in order from least to greatest. So to make a mapping diagram, what you do is you list all of your domain values from least to greatest in a little map. So let's start with the x. And now I'll throw in my y values. Okay, so now you draw a mapping diagram. -7 goes to 7, because it's negative comma 7. 5 goes to -5. -3 goes to 3. And -1 goes to 1. Okay, you try one. Pause the video here. Okay, so your domain in order from least to greatest should have been 0, 2. You don't need to write 2 again, because even though it's 0, 2, 2, because you already have 2 there, you do not need to repeat it. For your range, in order from least to greatest, you have 0, or you have -4, you have -2, and then you have 0. When you make a mapping diagram, you have 0 and 2, and then in your second column you have -4, -2, and 0. You should have had your lines connecting from 0 to 0, from 2 to -4, and from 2 to -2. Now the question is, are these functions y or y not? Let's look at the one on the left. None of my x values repeat. So yes, this is a function. Let's look at number 2, the one that you completed. Well, it looks like 2 has an output of -4 and an output of -2, which means no, this is not a function. And one last example. If we were talking about the domain of a circle, well, here's all my x values. All my x values are from here to here. So you can say that -5 is the lowest value and everything in between all the way to 5. So this kind of relates back to how we wrote our inequalities in chapter 2. Our y values go from here is the highest one to here's the lowest one. So it's everything in between -5 and +5. And now the question is this a function? And the answer is no, because you can see here that for x, it hits more than one point when you test it vertically. So an example here is at x here, 2 shoots out a 1, 2, 3, 4, 5, 6, 7. So you have 2, 7, and also you have 2, -1, 2, 3, 4, 5, 2, -5. So because x repeats, giving you different y's, this is not a function. And I have another example written for you here. And now we're going to talk about independent and dependent variables. Let's look at some situations. In the winter, more electricity is used when the temperature goes down and less is used when the temperature rises. We have to decide which is the independent and which is the dependent variable. Well, electricity depends on the temperature. Therefore, the electricity is the dependent and the temperature is my independent variable. Let's look at another example. The faster Ron walks, the quicker he gets home. Well, Ron's time depends on his speed. Therefore, the time is the dependent variable and the speed is what's independent. You try one. The cost of shipping a package is based on its weight. Pause the video here. You should have said that the cost depends on the weight of the package. Therefore, the cost is the dependent and the weight is the independent variable. And finally, let's talk about a function table. So basically, f of x is a new fancy way of saying y equals 7x plus 2. So if you ever see that, it means nothing else but just y. Because this is saying a function of x, y depends on whatever x is. So if x is negative 1, 7 times negative 1 is negative 7 plus 2 is negative 5. Now, since y is a function of x, so it depends on x, y is dependent on x, 7 times 0 is 0 plus 2 is 2. And finally, 7 times 1 is 7 plus 2 is 9. Now you come up with two values. If no domain is given to you, you choose your own. I'm going to pick 3 and I'm going to pick 6. 7 times 3 is 21 plus 2 is 23. And 7 times 6 is 42 plus 2 is 44. You are now done. Open up a baggie and start filling out the sheet. Choose your own domain values, which means they are not given to you like they were here. Remember, choose one negative always.